Okay, so now we'll write IPv6. So IPv4 was 32-bit address, right? So now IPv4 almost you can say it is about to be exhausted. Okay, so almost all the IP addresses, IPv4 address, are being used up and they are getting exhausted. Okay, so it is told that, say, some years back IANA has assigned the last block of IP address to some RAR or some service provider or something. Okay, so I suppose that by now they would have exhausted. Okay, now then they have developed something called IP version 6, and IP version 6, it's a 128-bit address. It's a 128-bit address, and it is represented in hexadecimal format. Hexadecimal format. So you know about the hexadecimal, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, F, right? So 0 to 9 and A to F. Okay, so now I suppose you know how we will write down the values of the hexadecimal to binary conversion as well, right? For 0, which is hexadecimal value, the binary will be 0, 0, 0, 0. And 1, it can be written like 0, 0, 0, 1. And 2, it can be 0, 0, 1, 0. And 3, it is 0, 0, 1, 1, and so on it goes. Till F, you will have this value. For F, you will have 1, 1, 1, 1. Okay. Now, so here, regarding IPv6, I told you it's 128-bit address. It is 128-bit address, but it is in hexadecimal format, and when it is written in hexadecimal, you will have 32 hexadecimal values. You will have 32 hexadecimal. So now let me write an example. So this is an example. Say ABCD 1 2 3 4 A2 B3 C4 D5 A6 B7 E8 F8. Okay, so 1 2 3 4 5 6. Okay, now 1 2 3 4 and A B C D. So how many values are there now? So if you calculate, say 4 8 12 16 20 24 28 32 hexadecimal values are there. Now, so here 32 hexadecimal values are grouped into 8 parts, or 8 groups. So this is the first group, second, third, fourth, fifth, sixth, seventh, and eighth. And each group consisting of how many hexadecimal values? 4 hexadecimal values. Okay, now we'll be writing, to separate each group, we'll be writing a colon in between. We'll be writing colon. In between, we'll be writing colon. Okay, here also we'll be writing colon. Here also we'll be writing colon. Okay, slash. Then here we do not have the class values. Here we only have the prefix length. Okay, so here we do not have the class, we do not have the subnet mask, we only have the prefix length. Okay, so suppose it is /64. That means 64 bits are reserved for network. Clear? So this is how you will write an IPv6 address. Clear? Okay. Now, IPv6 address or IPv4, I've told you about the IP version 4 transmission methods. Okay, so IP version 4 transmission methods, we had 3, which are transmission methods: unicast, multicast, and broadcast. Okay, here in IPv6 we actually do not have, say, the broadcast. Here we have unicast and multicast. Unicast is there, multicast is there, but the broadcast is not there. Instead we have something called anycast. Anycast. So unicast means one-to-one communication. Multicast means one-to-many communication. One-to-many. And anycast means one to nearest. Nearest. Unicast, multicast, and anycast. Okay. Now, again, so the multicast address starts with FF. Any address starting with FF is called multicast address. Okay. Now, unicast address again can be divided into 3. It can be divided into 3. The first is called unique local address. unique local address. Then the second is called unicast global address. And the third one is called linked local address. Unique local address, unicast global address, and linked local address. Okay. Now, unique local address, it is similar to the private IP. Similar to the private IP. And unicast global address, it is similar to the public IP. And linked local address, it is automatically created. Automatically created by the machine. Okay. So, of course, you know about the private IP, the public IP, right? Now, linked local address is actually, it is local to a particular link. It is local to a particular link. And say its relevance will be, say it do not have any relevance outside the link. Okay, outside the link, so it doesn't have any relevance. That means, suppose, okay, here we got some computers. Okay, here we got some switch, and here we got a router. Okay, suppose, okay, yes. So now, suppose that we have a router, switch, and computers. Now, if at all you give an IPv6 address, or if at all you enable the IPv6, then these computers or these devices will automatically generate something called link local address. Okay, now this link local address, it starts with FE80. It starts with FE80. FE80 starting. Okay, and it is local to that particular link. Link in the sense, it is local to that particular network. Okay, so here this computer has got a link local address. What is it? FE80, some values. And this machine has got a link local address, FE80 and some values. Here the machine has got a link local address, FE80 and some values. Here even the router interface also got a link local address, FE80 and some values. Okay, now this link local address, it can be used for this router. This link local address, the fast internet 0/0's link local address, can be used within this network only. Okay, it cannot be used with other network. Suppose you have F0/1 here, it cannot, this address cannot be used towards the other end. Clear? Okay, that's why it is called link local, local to that particular link. Clear? Okay, then
8 bits for network. In this 8 bits for network.
Not really, 48 bits.
48.
Okay, now, so here, yes, now coming back. So I've written an IPv6 address here. Okay, this is the IPv6 address. Okay, and this IPv6 address, I told you it has got 128-bit value. It's a 128-bit address. Now, so some IPv6 address can further be shortened, not this one. Okay, this can be only written like this, but some IPv6 address can further be shortened. Let us discuss how we can shorten the IPv6 address. Okay, so suppose if you have an address like this, 0001 colon 000b colon 00ab colon 1234 colon 0001 colon 0002 colon 0003 colon 00440. Okay, so 1 2 3 4 5 6 7 8 slash, suppose say 120. Okay, if you are given with such an IP, here you can see each group, they got some preceding zeros, right? So before the value you got some zeros here, and these zeros can be omitted. Each in a group, when you consider each group, if you have preceding zeros, you can omit that zeros. Okay, so that means you can write it like this: 1 colon b colon ab colon 1234 colon 1 colon 2 colon 3 colon 40. slash 120. It can be written like this. So this is one method to shorten an IPv6 address. Now some address can further be shortened again. Okay, again let me write another address here. Say 0001 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 1234 colon 1234 slash suppose slash 20. Okay, so if I write like this, this address can again be shortened. So this address, first it can be shortened like this: 1 colon 0 colon 0 colon. So how many zeros are there? 1 2 3 4 5. Okay, so 1 2 3 4 5, then 1 2 3 4 colon 1 2 3 4 slash 20. Okay, now this address can again be shortened like this: 1, instead of all these 0 groups, you can write a double colon. You can write a double colon. So 1 double colon 1 2 3 4 colon 1 2 3 4 slash 20. So you have reduced it, or you have shortened it, right? Significantly you have shortened it. Okay, so this is how you will shorten the IPv6 address. Now you need to be careful. So in an IPv6 address, you need to you can use this double colon only once. Only once you can use this double colon. You shouldn't use the double colon twice in an IPv6 address. Clear? If you use twice, then that is wrong. Okay, so if at all they are having such a value, suppose if they are having such a value, okay, suppose the address is like this. Okay, so here suppose again, let me again write it down. Here it is 1. Okay, or suppose B. Okay, and here it is 0. So you can write down the say double colon either here or here. Okay, you shouldn't be writing at both the places. Clear? So this address can be written like this. Either you can write it down like this: 1 double colon say B colon 0 colon 0 colon 1 2 3 4 slash 20. Okay, or you can write it like this: say 1 colon 0 colon 0 colon 0 colon B double colon 1 2 3 4 slash 20. Clear? Okay. So this is how you write an IPv6 address. Okay, now coming back to something else. Say here I've told you about the link local address, right? Link local address, I told you, say it is starting at FE80 and it is automatically created by the machine. So now if it is automatically created by the machine, of course, but it is created by using a method called EUI64. It is created by a method called EUI64, extended unique identifier. That's what UI is, extended unique identifier, EUI64 method. So now we are gonna consider EUI64 method. Okay, now in this method we will consider 64 bits are network portion. 64 bits are network portion. Okay, and the rest 64 bits are host portion. The first 64 bits are network portion and the rest 64 bits are host portion. Okay, now so if at all a router or if at all a computer wants to generate this, say the link local address, what it will do is that, say the network portion will be kept constant, FE80. Okay, double colon. Now so here 64 bits are assigned for host. So to assign the 64-bit host bit, what they will do is that they will take the 48-bit MAC address. They'll take the 48-bit MAC address. Consider that the MAC address here, the MAC address of the machine is this one, 0001.82b3.c4d5. Suppose this is the MAC address. Then what they will do is that they'll take the MAC address, they'll split it into two halves. They'll split it into two halves. That means they have split it into two halves. Okay, so 0001, okay, dot A2, then B3, then C4D5. Okay, now you need 64 bits for the host portion. So how many more bits you need? 16 more bits you need. Okay, so what they did is they added a 16-bit value, a constant value. Okay, and this value is FFFE. It's a constant value. So what they will do is that they have inserted this value, the constant value, in between the MAC address, FFFE. Okay, so now it has become 64-bit. Now it has become 64-bit. Now what they are going to do is, okay, so I told you each hexadecimal value consists of 4 bits. Each hexadecimal value consists of 4 bits. So this value can be written like this: 0000000000000001. Okay, so this is the first 0, second 0, third hexadecimal 0, and the fourth value, which is hexadecimal 1. And which is the 7th bit? This is the 7th bit. And that value will be, say, inverted. That value will be inverted means the value will be like this: 00000010. Okay, that value will be inverted. And then again 00000001. Okay, now this value, when we convert it into this hexadecimal value, it will become like this: 0, this value is 0, and what is this value? 2 is the value. Okay, then this is 0, then this is 1. So the value here is 0201. Okay, 0201, then A2FF, FEB3, and C4D5. So this is the value. This is to change. Say this value has been changed, so this value remains a constant there. So that bit is called I bar G or something, U bar G or something. So that is changed here. Okay, to represent this MAC address is changed. Okay, then what you will do is that you will add this FE80. So now the IP address is FE80:0201:A2FF://FEB3:C4D5/64. Okay, so this is how they will calculate the link local address. Any doubt? One more example. Same. Say here. Suppose here, let me take the packet tracer. Okay, I'll show it to you. Suppose, and again, when you implement IPV6, you need to take the supporting devices, the IPV6 supporting devices. Okay, so 2811 series router is one device which supports IPV6. So I've taken the 2811 series router. Now, so here you can see, yes, it will take some time. Okay, now let me take a MAC address. Okay, so interface, suppose gigabit ethernet 0/0/0. Okay, sorry. So show IP interface brief. Let me check it. So here fast ethernet. Okay, so show interfaces fast ethernet 0/0. Here you can see the MAC address of fast ethernet, which is 00D0BA635901. Okay, so this is the MAC address. Okay, so let me take the notepad. So this is the MAC address. Can you read it at the back? Okay, so what they are going to do is, if at all they want to calculate the link local address, what they will do is that they will split this into two parts. Yes, they are split into two parts. The MAC address into two parts. Then what they will do is that they will add certain values, some constant values. The value is FF, yes, FE. Okay, then what they will do is that here the 7th bit. So 7th bit in the sense here you can expand it like this. Okay, this 00D0 can be expanded like this. 0000 again 0000 and D when you expand, then I suppose the value is something like this. Okay, even 1011. Okay, so 1011 is the value for D. Okay, then again 0000. Okay, this is the value for expansion of 0 0 D 0. Okay, then what they will do is that they will invert the 7th bit. So 1, just give me a moment. Okay, so 0 0 0 0 0. Okay, 0 0, the 7th bit is next one. Okay, so it will be changed 1 0. Okay, then this value will remain the same, 1 0 1 1 and 0 0 0 0. Now the value will be, what is this value? 0. Okay, this value is 0. And what is this value? 2. Okay, and what is this value? D. Sorry. Okay, this is 1 0 1 1. Okay, so this value is D. And what is this value? 0. Okay, then colon BAFF colon FE63 colon 5901. Okay, now this is the host portion. Now to make it as the IP address, the IPv6 address, the link local address, they'll add FE80 double colon in front and this value. So this is the address. Okay, now if you want to check it, okay, so here suppose that I'll go to the config mode and I'll execute the command do show IPv6 interface brief. Okay, so first let me make it up, guys. Let me just connect it. And this is not needed for now. Suppose if at all the switch is needed. Switch or one device should be connected to that interface so that that interface will become up. Okay, so now let me just go and make that interface up. To make that interface up, we'll go to that interface fastnet 0/0 and we'll give no shut. Okay, and then when you check do show IPv6 interface brief, it is not assigned. Okay, so interface again fastnet 0/0. Suppose I'm assigning it. I was supposed to tell you or teach you this later. Okay, suppose that I'll teach you again. Let me just give an IP. Okay, yes, here now you can see a link local address has automatically been created, and if you check the link local address, it will be same as the one that we calculated. You can see this FE80. Okay, FE80, and now this 0 can be omitted. Okay, because it is coming in the first, so this 0 can be omitted. So 2D0. Now BAFF FE63 5901. So this is how they'll calculate the link local address. Clear? Okay. Now coming back to the configuration things and all. Okay. So suppose if at all you want to say, if at all you want to implement the IPv6, I told you, so you need to have the devices which support IPv6. Okay. So if at all your device does not support IPv6, you will buy the device which supports IPv6. Okay, then again, say in the computers also you can give the IPv6 address. So to give the IPv6 address to the computer, you will go to the, say, the network connections panel. Okay, you will go to network connections. Okay, you will go to network connections, and what you're going to do is you're going to click it. Whichever interface you want to give the IP, or whichever NIC card you want to give the IP, you will double click it, and instead of taking the previously we have taken the IPv4 to configure the IPv4 address. Now to configure the IPv6 address, we will click on to this IPv6 address. Then here we will use click on to this use the following IPv6 address. There we will give it, say suppose if at all I want to give some IP address like this 1000:1. Then I'll give the prefix length, suppose 72 or 80 or whatever is the prefix length, I will give it. And if at all you want to give the default gateway also, you will give it. Okay, suppose 1000:100 is the gateway. Clear? And then we'll click OK. This is how you will set the IPv6 address in the computer. Okay, now again implementing IPv6 in the in the existing network. So if at all you want to, so I told you need to have the IPv6 supporting devices. If you're having the IPv6 supporting devices, say along with IPv4 you will add or you will do IPv6. Okay, along with IPv4 you will do IP version 6 as well. So IPv4 and IPv6 are maintained separately. These things are run separately. Okay, so no need to worry, they will run separately. Okay, the tables are maintained separately, the protocols are running separately, so you don't need to worry about it. Okay, so parallelly when you run IPv4 and v6 together, then that is called dual stack. That's called dual stack. Okay, so you can run v4 and v6 at the same time. Okay, then again one more thing, suppose that you are doing, so let me just create a small config here. Okay, we'll just create some small config and we'll do some routing as well, the basic level routing and the basic level things. Okay, so now to say suppose we are having two computers. Okay, the first computer, suppose this is connected to say the switch. Okay, and then it is connected to the router. Okay, so again this is the router, and suppose this is the Bangalore branch. Okay, now consider that this is the Delhi branch. In the Delhi branch also we can have a switch and we can have a router as well, sorry, a computer, say multiple computers are there. Okay, so now let me connect it. Okay, just give me a minute more, guys. Okay, suppose this is the topology. Okay, and in this topology, so here suppose, let me take the epic pen as well. Okay, so here this LAN, the Bangalore branch LAN, suppose this Bangalore, this is the Bangalore branch. Okay, and this is the Delhi branch. Now the Bangalore branch LAN, we are configuring it as 1000:/64 range. Okay, so I'm configuring this as 1000:1, and suppose this router has been configured with an IP 1000:100. So here the gateway will be 100. Gateway will be 1000:100. Clear? Okay, so here let me draw it one more time. See here, so suppose this is 1000:/64 and this is 1000:1/64, and here it is 1000:100/64. Okay, now here in the Delhi branch, here suppose we have got 2000 network. Okay, 2000:/64, and here I am giving an IP 2000:1/64, and here it is 2000:100/64, and to interconnect each other we are using the network 3000. 3000:/64, here it is 1 and here it is 2. So shall we do this? Okay, so first let me take the screenshot. So now so we'll go to this computer and we'll give the IP like this. So here we are going to give, so here also you can see the link local address. It is automatically created by using the previous method itself. Now this IPv6 address, so here for the computer this is 1000:1. Okay, then slash you will give it as 64. Okay, then here the default gateway is 1000:100. Okay, now the same thing we are going to give it in the next computer as well. It is designed with an IP 2000. So 2000:1/64. Okay, and then 2000:100. Okay, now so here you assign the IP address to the computer. Now to assign the IP address to the router. Okay, so now we'll go to this one and then we'll go to the config mode. Now which interface you want to assign? Here you will be assigning this IP 1000:100 to fastnet 0/0. Okay, so we'll go to fastnet 0/0. So first let me give the host name. Host name, suppose this is the Bangalore router. Okay, then we'll go to interface fastnet 0/0. Then I'll be giving the IP. Now the previous command was something like this, IP address. Now if you are configuring IPv6, almost all the commands will be like this, IPv6 address. Instead of IP you can replace it with IPv6. So IPv6 address 1000:100/64. Clear? Then we'll give no shutdown. Okay, now the interface has come up. So to check it again, we'll execute command do show IP interface brief. If you execute, you will not view it. Okay, do show IPv6 interface brief. You can see this has come up. So here this fastnet 0/0 has come up. So it is up state, and this is the IP address, and this is the link local address. Clear? Now again, if at all you want to configure this interface, so you will exit and here you will go to that interface fastnet 0/1, and you will mention the command IPv6 address. Then what is the IPv6 address that we will give here? It is 3000:1/64. So here we will give 3000:1/64. Okay, and then we'll give no shut command as well. Okay, again we'll check do show IPv6, so interface brief. You can see it has been configured with the fastnet 0/1. It is up bar down because say the other end also you need to configure. Okay, then only it will become up. So here it has been configured with the IP 3000:1. Clear? Okay, now again we'll go to this routers, the Delhi branch, the basic. We are only doing the basic configs. Okay, so now interface fastnet 0/0. Okay, and then here we have the fastnet 0/0. We have the IP. Say for fastnet 0/0 we have 3000:2. Okay, so we'll give IPv6 address 3000:2/64, and we'll give no shut. Okay, again we'll go to this one fastnet 0/1 here. Okay, and we'll give the IP say 2000:100. Okay, so exit. So I didn't give the host name, so let me give the host name. I forgot to give it, Delhi. Then we'll go to interface fastnet 0/1. I'll give the IPv6 address, and that address is 2000:100. Okay, so it is 2000:100/64 and no shut. Okay, so again do show IPv6 interface brief. You can see both the interfaces are up bar up, and both the interfaces have been configured with the respective IP addresses. Clear? Okay. Now if at all you want to do the routing, Okay, so here, even here also the routers maintain the routing table. To view the routing table, we'll go to the config mode, or we'll go to the privilege mode, and we'll mention the command show IPv6 root. So IP root will not work because it shows the v4 routing table only. So IPv6 root, here you can see the IPv6 routing table, and here you can see in IPv6 routing table, say 1000. So this is the Bangalore branch. Bangalore branch is connected to 1000:/64, and also to 3000:/64. It doesn't know about 2000 network. So shall we mention that one? Okay, so the same here, when you go to the say this Delhi router, do show IPv6 root. Okay, you only have 2000 network and 3000 network. You do not have the 1000 network. So again, we'll mention the routing. So here also you got static routing and default routing, and also the OSPF, AGRP, RIP, etc. Now we'll be configuring the static routing. So to configure the static routing, we'll go to this router, the Bangalore one. We'll go to the config mode. And what is the command, guys? For the IPv4, what was the command? IP route. For IPv6, what will be the command? IPv6 route. Okay, so the command is IPv6 route. Okay, then we'll give the unknown network, which is 2000. 2000:/64 is the unknown network. Here we do not have the subnet mask, right? So we'll give the prefix length. Then we'll give the next hop address. So yes, so here what is the next hop here for the Bangalore router? For the Bangalore router, to go to the 2000 network, the next hop is 3000:2. So we'll mention 3000:2. Clear? Now do show IPv6 root. You can see the statically mentioned root is there, 2000:/64. You can go via 3000:2. It's simple, nothing else. Okay, now so here again we'll go to this one. Again we'll mention the unknown for Delhi router, which is unknown network 1000. So here it doesn't know about, say it knows about 2000 and 3000, it doesn't know about 1000. So here IPv6 root, then 1000:/64, then the next hop address, here it is, say 3000. For this Delhi router, the next hop address is this one, 3000:1. Done. Okay, so when you check it, the v6 table, the v6 routing table, you can see 1000 has been mentioned statically, and the next hop address is 3000:1. Okay, now if you try to ping to the other end, suppose 2000:1, which is this computer. Okay, if you try to ping, you ought to get the ping. We'll check it. Will not get it. Okay, because we have done everything. But again, let me tell you, by default the IPv6 routing is disabled in all the routers. By default the IPv6 routing is disabled in the routers, and you need to enable it. Only if you enable it, you will get the output. So if you if you do not enable it, you will not get the output. Okay, so to enable the IPv6 routing, we'll go to the config mode and we'll give the command like this: IPv6 unicast-routing. This is the command, IPv6 unicast-routing. This is the command to enable the IPv6 routing. Okay, so IPv6 unicast-routing. Yes, sorry. The same thing I'll be implementing here as well. Okay, IPv6 unicast-routing. Now the routing is enabled. Now if you try to ping, they'll ping. Now you can see you're getting the reply from 2000:1. Now when you trace RT, if at all you want to trace route it, okay, trace route 2000:1, you can see the path. It is first going to say 1000:100. That means this router wants this Bangalore router is fast internet 0/0. Then you can see 3000:2, which is this router 2. So the Delhi router is fast internet 0/0. Then it will go to that computer, which is 2000:1. Clear? So this is how you will do the IPv6 configs. Any doubt? Okay. Now, so this is the static routing. Now let me take away the static routing. Let me take away the static routing by giving no. Okay, so do show IPv6 route will not have the static route. Now the static route is deleted. Now instead, let me give the default routing. To give the default routing, the command is like this: IPv6 route, and I'll be writing like this: /0. This is the default route. /0. Then I'll mention the next hop address, which is 3000:2. This is how you will mention the default route in the IPv6. Double colon means, say here I told you double colon. If at all you have continuous zeros, you will represent it by using the double colon. So here all the 128 bits, it has become 0. So that is why it has got double colon /0. Whatever be the address, whatever be the subnet mask, just forward it to so and so IP. That's the default route, right? So if at all you want to check it, say do show IPv6 route. You can see /0 for the default route. Just go to, or just send the packet to 3000:2. Clear? So this is the default route. Any doubt? Just simply I'm telling this like this thing. So again, lot of theory are there. Okay, textbook, please read it. Okay, now again let me take away this command also. Okay, no, then do show IPv6 route. Again the static route has been deleted. Now again let me delete the static route from here also. Do show IPv6 route. When you check, you got the static route. Let me delete it. Okay, after deleting, do show IPv6 route. It is deleted. Now shall we do the OSPF as well? The working and everything is same. They'll be in the say initial or in the init stage, then they'll move on to the two-way, then so the working is the same. So it's the configuration. Okay, so this OSPF is the OSPF version 3 that we use. OSPF version 3. Okay, so to implement that, what you're going to do is you'll go to the config mode, and then you will mention the command like this: IPv6 router OSPF. The command is IPv6 router OSPF. Then you will give a process ID, suppose 100. Okay, and then you can see here OSPF v3 process 100 could not pick a router ID. Please configure manually. Okay, because here what happens is that we haven't configured any v4 address, right? So if at all the v4 address are not configured, then they will not be able to automatically pick up the router ID. Okay, and so this error is shown. Okay, so if at all you have configured some interface, some IPv4 address and all, they would have automatically taken it. But now they cannot take it because we have not configured it. Neither we have configured the router ID, nor we have configured the IPv4 as well. Okay, we have studied it, right? Yes or no? Okay, so now we are into the OSPF where we will give the router ID manually. The command is we are in the OSPF, so config-rtr, and we'll give the command like this: a router-id, then suppose the router ID is 1.1.1.1. Okay, then we will exit from that OSPF. We'll exit from that OSPF and we'll enable the OSPF in the interface level. We'll enable the OSPF in the interface level. So we'll go to the interface fast Ethernet 0/0, and I'll enable the OSPF like this: IPv6 OSPF 100. So this is the OSPF 100 that I've enabled. OSPF 100 area 0. Clear? This is how you will enable the OSPF in the interface. Okay, again I'll go to the next interface FA0/1, enable the same thing. IPv6 OSPF 100 area 0. Suppose everything is in area 0, I'll be executing area 0 here. Clear? Again the same thing here. We'll go to the config mode, we'll mention the router. So the command is IPv6 router OSPF suppose 200. Again the issue is shown, so I'll give the router ID like this. Suppose 2.2.2.2 is the router ID. Okay, router ID is in IPv4 format. Then we'll go to the interface fastnet 0/0, we'll enable the OSPF IPv6 OSPF 200 area 0, and again interface fastnet 0. So now you can see, okay, now you can see, say the OSPF has formed the adjacency. Okay, now if you enable this one, if you go to interface FA0/1 and enable the OSPF, what happens is that they have already formed the adjacency, so they will share the routes. They'll share the routes, and if you check the routing table, say show IPv6 route, you can see the routing table. So the Delhi branch now knows about the 1000:/64 network. Okay, similarly this router, the Delhi router, might have shared 3000 network. Okay, so when you check it, okay, do show IPv6 route, you can see yes, the router might have shared, and the router might have shared the 2000 network, and they have shared it. Clear? Any doubt?
Suppose if Delhi configure with IPv6 and Bangalore with IPv4.
Delhi
Configure with IPv6 and Bangalore with IPv4.
IPv4, then no communication will be there. Okay, so for those things, if at all you want to communicate, you need to do extra tunneling, extra things and all. Okay, some V6, even I forgot, what is it, say
why don't we use VPN?
which one?
No sir, for communicating for IPv6 and IPv4, can we use VPN?
Yes, it's not the VPN, it's called 6-to-4 tunnel. It's called 6-to-4 tunneling, those things and all. So tunneling is used. Okay, tunneling, but extra configs needs to be done. So by default it won't work. Okay, by default only the IPv6 to V6 only work. Okay, V6 to V4 won't work. Okay, yes, so this is the IP version 6. Clear? Now one thing I forgot. Okay, so now again, let me just give you some show commands as well. So to view the neighbor table, the command is show IPv6 OSPF neighbor. Okay, so if at all you want to see the OSPF related details, so to the previous commands just give an IPv6, to the v4 commands just give an, say, add the v6 here, IPv6, and you will get all the OSPF commands, say almost all the commands. Okay, now so now that we have one more thing, subnetting. One more thing of subnetting. Shall we go with subnetting?
Yes.
Okay, so after subnetting we'll give you a break. It's just a matter of maybe 5 to 10 minutes, that's it. Okay, so after the subnetting we'll give you a break. So just let me do it, let me show it to you. I'm not gonna teach you like what we have done in IPv4 and all, right? So I'm gonna just teach you how it can be done. Just I'm gonna show it to you, that's it. Okay, so suppose that I have an IP, say suppose 2000 colon, or say 2000 colon 1234 double colon slash 72. Okay, so or suppose slash 64. Don't want to make it complicated. Okay, so this IP can be written like, and I have some requirements. Okay, my requirements are like this. Suppose I need to have, say, in a network I need to have 500 machines, and then I need to have 10 machines, I need to have 20 machines, I need to have 30 machines, I need to have 60 machines. These are my requirements. Then what I'm gonna do is, first let me expand this address. I'm gonna expand this address. So to expand this, it will be like this: 2000 colon 1234, okay, colon 0000 colon 0 0 0 0 colon 0 0 0 0. So how many zeros will be there? Sorry, again this one, again this one. So 1 2 3 4 5 6 7, one more. Okay, now slash 64. So this is the entire address. Okay, now suppose I'm taking only this one. I'm taking only this one. So I'm writing it like this: 2000 colon 1234 colon everything, all these values I have represented using double colon here. Okay, and this is 0 0 0 0 slash 64. Okay, now I have taught you each group consists of 16 bits, or each value, each hexadecimal consists of 4 bits. So I can expand it like this. This value I can expand it like this: 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. So shall I expand again? Okay, so this time I'm gonna expand it like this: 2000 colon 1234. Now double colon. So now these portion I have expanded using the binary. Okay, using the bitwise. So here 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, now slash 64 is the IP. Okay, so now what I'm gonna do is, now we are gonna do the VLSM. So to do the VLSM, what you're gonna do, you're gonna take the highest number of machines first. So the highest number of machines is 500 here. Then the second requirement is, say, 60. Okay, 60 30 20 10. So let me write it down: 60 30 20, and then the value is 10. Okay, then what you're gonna do is, I'm gonna write it down like this: say 1 2 4 8 16 32 64 128 256 512 1024 2048, etc. Okay, and my requirement, can you see at the back?
Yes.
Everyone? Okay, so what we are going to do is, say for 500 machines we will draw a line, right? For 500 machines, where will we draw the line, guys?
6th bit on the left.
6th bit from the left? Nope. 1 2 3 4 5 6. Okay, so yeah, from the left 6th bit. Okay, 1 2 3 4 5 6. Or you guys told, say between 512 and 256, right? It's not the 6th bit, it's the 7th bit. Okay, so it is where you draw the line, right? So between 512 and 256 you will draw the line. Okay, if you draw the line, so let me, yes, if you draw the line like this, then you can write the address like this. Okay, the address can be like this: 2000, okay, colon 1234. Okay, and everything is 0 here. Everything is 0. So you can write double colon there, right? So what you will do is that you will write double colon slash. How many bits are reserved for host now? For host, how many bits are reserved?
9 bits.
For host, how many bits are reserved?
118.
Bits, number of bits.
9 bits.
9 bits. Okay, so 1 2 3 4 5 6 7 8 9. 9 bits are reserved for this host. So how many bits are reserved for network?
119.
Yes, so 128 minus 9, you will get 119. So the address will be, this is the address, and then you will write slash 119. Clear? Now what you're going to do is, so now you will write the same thing: 2000 colon 1234 double colon, now 0 0 0 0. Now 0 0, to the left side of the line you will add a 1. To the left side of the line you will add a 1. Here, Kevin? Okay, to the left side. So here we have the line here. to the left side of the line we will add a 1. So 0 plus 1 will give you 1. Okay, then this value will be 0. 0 0 0 0 0 0 0 0. Okay, now the requirement is 60 machine. So for 60 machine, where will you draw the line? You will draw the line between 64 and 32. You will draw the line between 64 and 32. Clear? So now the address will be like this: 2000 colon 1234. Okay, now this is 0 here. Okay, the value, so this is double colon. Now the first value is 0. Then this value, what is the value? The value is 2. Okay, 0 0 1 0. The value is 2. Okay, so the value is 2 here. So 0 2, and then the value is 0 0. Everything getting it? Okay, so the value is 0 0 slash. How many bits are assigned for the network now? 120. Yes, so you have assigned, say, or you already had 119, now 120, 121, 122. 3 more bits have been added, so it will become slash 122. Clear? Now for 30 machine. So again you will write it down like this: 2000 colon 1234 double colon. Okay, 0 0 0 0 0 0 1 0. Now 0 1 0 0, because to the left side of the line you will add a 1. Okay, and again 0 0 0 0. Now for 30 machines, where will you draw the line? You will draw the line between 32 and 16. That means you have added one more bit. You added one more bit. Now the address will be like this: 2000 colon, this is a colon. Okay, 1234. Now double colon, and this value 0 2, and this value is 4. Okay, so you will write it 0240 slash 123. Clear? Now for 20 machines, 2000 colon 1234 double colon 0000 0010. Now 0110, because to the left side of the line you will add a 1. Okay, and then 0000. This value will be 2000 colon. Now for 20 machines, again you will draw at the same place. For 20 machines you will draw at the same place. So now this value will be, say, 2000 colon 1234 double colon the 0 2, and what is this value? 6. Okay, so 0 2 6 0 slash 123. Okay, now for 10 machine, 2000 colon 1234 double colon 0000 0010. Now to the left we are adding 1 again. Okay, so you already have a 1, right? So what you're going to do, so here when you add, so here you already have a 0 here, the 0 is written down, and here you already got a 1, so 1 plus 1 you will get is 2. 1 plus 1 is 0 with a carry 1 in binary. Okay, again 1 plus 1 0 with a carry 1. So this is 1 now. Okay, yes. Now 0 0 0 0. Now for 10 machines you will draw the line, say after, or you will extend one more bit. You will extend one more bit. You will draw between 16 and 8. So this address will be like this: 2000 colon 1234 double colon. So this address is 0. This is 2 itself. So 0 2, and this is 8. 80 slash 124. So this is how you will submit it. Clear, guys? Any doubt? Okay, fine. Okay, so you can note it down. You can then take a break as well. Okay, 5 minutes break is sufficient, right? Okay. Or if at all somebody can take a snapshot and then put it in the group, that is also fine. Okay, a screenshot or a photo and put it in the group, that is also fine. So we'll get back at say 9:10 a.m. So this is the IP version 6. So after the break we will continue with the next portion. Clear? Okay. And one more thing, theory is there, read the textbook. Okay. Yeah. So guys, yes, so this is it. Now coming to the next portion, so which one is it? So the IPv6 is complete. Okay, now we'll go to some theory. SSH FHRP. Okay, so let me complete SSH now. Instead of theory, let me complete SSH. Okay, did I teach you telnet? No. Okay, so first you can write telnet, the remote access procedure. A remote access procedure. So you are accessing via the VTY port now. Okay, I've told you how you can access via the console port, right? So if at all you have the router, so let me take paint again. So here, where is it? Okay, if at all you have the router and if at all you have the console port, from the console you will connect it to the computer, right? And you will.
Yes, sir.
Yes.
I think we already discussed about this telnet and SSH port.
Done.
Yes, we have covered these two.
Okay. No worries. Then you guys told we didn't cover it. Covered. Okay. Then leave it. Then the next one. Okay. Now, so then the theory. So now you got some theory portions, QoS, traditional versus SDN and all. So here, so first we'll go with, even before that, we'll go with the FHRP. Okay. So you can write the heading FHRP. FHRP. And that's why, because usually I'll discuss the telnet and SSH when I teach the switching. Okay, by the switching basics, when I discuss the switching basics, I'll really usually go with the telnet and SSH. That's why I asked you twice, did I cover it or not? Okay, leave it. Now, so now, sorry. Okay, so now we'll go with FHRP. So FHRP here, it means first hop redundancy protocol. First hop redundancy protocol. First hop redundancy protocol. Which, what it does is that it automatically changes the route. Okay, you can say if at all you are having say 2 or 3 internet connections. Suppose we are taking 2 internet connections. Okay, so if at all one fails, what we will do? We need to manually change it to the other one. Okay, whereas this, if at all you implement this FHRP, then if at all the first service provider fails, it will automatically go to the secondary one. That's the FHRP. Now FHRP has got certain protocols. These are actually, FHRP means a family of protocol. So it is a redundancy protocol and it consists of many protocols. The first protocol is HSRP. In FHRP itself, it consists of many protocols. The first is HSRP, Hot Standby Redundancy Protocol. Hot Standby Redundancy Protocol. Hot Standby Redundancy Protocol. Then the second one, it is VRRP, Virtual Router Redundancy Protocol. Virtual Router Redundancy Protocol. Then the third one, GLBP, Gateway Load Balancing Protocol. These are the 3 protocols: HSRP, VRRP and GLBP, which comes in this first hop redundancy protocols. Okay. Now we'll go with HSRP, Hot Standby Redundancy Protocol. Okay. So you can write HSRP. Suppose we got connections like this. We got a network like this. Okay. Here the network is suppose 10.0.0.0/24 network. Okay. Now suppose here .1, .2, .3, .4, etc. Okay. Now here suppose we got an internet connection. Suppose this is the Airtel. This is the Airtel connection. Okay. And suppose this is the BSNL connection. This is the BSNL connection. Now, so here we are connected to the service provider, and then the service provider to, say suppose you are getting the Google. So suppose this is the Google. Okay. Now consider that here we have assigned the IP .100, 10.0.0.100, and here we have assigned the IP 10.0.0.101. Now when you configure the HSRP, here, what happens is that one router, suppose this Airtel router is the primary connection, is the primary internet connection. Okay, and this is the secondary internet connection. Now when you configure HSRP, the primary internet or this router will act as the active router. And the other router will act as a standby router. Now both the routers have been configured with the virtual IP. There is actually a virtual IP which is configured in both the routers. Suppose the virtual IP here, it is this one. Suppose the virtual IP, it is here 10.0.0.200 is a virtual IP. Virtual IP 10.0.0.200. Okay, here also we'll configure virtual IP 10.0.0.200. Both have been configured with the same virtual IP. And here for the machines, the gateway will be .200. The gateway will be for .200. Okay, so the virtual IP will be set as the gateway. Okay, now I told you Airtel router is acting as active and the BSNL router is acting as standby. Whoever is acting as active will take or will use this virtual IP. Whoever is acting as active will use this virtual IP. That means the virtual IP will be used by the Airtel router, and so all the internet packets will be sent through the Airtel router. Clear? So now all the internet packets are sent through the primary internet connection, that is the Airtel connection. Okay, now again let me tell you, the Airtel connection, the primary connection and the secondary connection, these two, if you are configured them with the HSRP protocol, they will send certain hello packets. Now for every 3 seconds one hello packet is sent. Okay, now if at all this link goes down, suppose this link goes down, there is no connection to the Airtel. If at all that link goes down, what happens is that this BSNL router, it will wait for default of 10 seconds. Which is called hold down time. Okay, they'll wait for default of 10 seconds. If they didn't get a hello from the Airtel router after the 10 seconds, the BSNL router will change its state to active. And the Airtel router will change its state to standby. Clear? Now if at all when the state is changed to active, I told you the active router will start using the virtual IP. So the virtual IP will be used by the BSNL router. That means all the internet packets will be now going through the BSNL connection. So you don't have to do anything. So it will automatically switch to the BSNL connection. Clear? Okay, so this is how if the Airtel goes down, say the BSNL will come back, or if the BSNL will be turned on. Clear?
Sir,
Yes.
one small doubt. The dot 100 will be down or the other side of the Airtel when is down?
So we were discussing about dot 100 being down. Okay, now
LAN side.
yes, the LAN side. Okay, again, so let me again tell you. So this router, I'll come to your question about the WAN also. I'll come to that also. Okay, now, so now the active router, I've told the Airtel router is the active router. Okay, and the BSNL router is the standby router. Now suppose that this has come up, dot 100, this link has come up. If it comes up, you will think that this will go back to standby and this will go back to active, but it will not go back by default. It will not go back by default. Only if you enable a property called preemption. Only if you enable the property called preemption, then it will go back to the older state. That means if at all the link comes back, if the preemption is enabled, the BSNL router will go back to standby and the Airtel router will go back to active. So the active router, which is the Airtel router, will use the virtual IP, which is 10.0.0.200, and all the packets to the internal will be forwarded to the Airtel router. Got it? Okay. Now I told you that Airtel router is active router and BSNL router is standby router. How to make it active and how to make it standby? To make it active, what you're going to do is there is a value called priority value. There's a value called priority value. So the priority value, so that value is the value can range from 1 to 255. The value can range from 1 to 255. Suppose the priority is 101 here. Okay, and here the priority is 100. That means the router which is having the higher priority will become the active router. Clear? The router with a higher priority will become the active router. Okay. Now the next thing. So if at all this link goes down, if at all the WAN link is going down, suppose the Airtel link has gone down or the Airtel is down now, we do not have the issue with our LAN. The Airtel link has gone down. So what happens is that they will usually say, or that will be working fine. They will be sending the hello packets and they will receive the hello packets. Right? The hello packets will be received. So who is the active router? Airtel will still be the active router because hello packets are being received. Now, so Airtel will be using the virtual IP. So all the packets will be forwarded to the Airtel router only. Okay. Now Airtel router, does he have the connection now? He doesn't have the connection. So what he will do is that all the packets will be forwarded to the Airtel router and the Airtel router will redirect the packet to the BSNL. And this is called, say, hairpin issue. This is called hairpin issue. So to avoid the hairpin issue, what you're going to do is that, say, if at all this link goes down, the WAN link goes down. Okay, the WAN link goes down. Say you will configure the HSRP in such a way that, say, here we will configure something called track. Here we will configure something called track. Track this link. Track this link. If at all this interface goes down, change its priority by 2 or decrease the priority by 2. If you decrease the priority by 2, what happens? The priority will now be 99. The priority will become 99. If the priority becomes 99 and here the priority is 100, what happens? Who is having the higher priority? BSNL is having the higher priority now. So BSNL router will change to active and this will change to standby. Clear? So if the WAN link goes down, you can use certain track commands. You can track the interface and you can reduce the priority so that, say, the other router or the other service provider will become active and thereby they will use the virtual IP and thereby all the internet packets will be sent through the other, say, service provider. Clear? Any doubts here? Okay. So whoever has asked the doubt, I suppose you have understood. Got it? So whether it's the WAN link or the LAN link, it doesn't matter. So if at all the connection goes down, it will change. Okay. Yes. Configuration is not there. Okay. Only the theory is there. Okay. Don't worry, you will study that in CCNP. Okay. So this is the say FHRP, first hop redundancy protocol, and this is HSRP that you have studied now. So online guys, any doubt? Okay, I suppose.
No, sir.
Okay.
Sir, in this design, in this topology, if we connect another link between the two routers,
Another link between the two routers. Okay.
so that will be a better, lens purpose. I mean,
Sorry, that will be a better.
the performance will be very better. I mean, from the design perspective.
Design perspective will be taking many things into consideration. Even I am not well aware of the design things. Okay. I think they'll be considering the traffic things. They'll be considering unnecessarily we won't be connecting, right? So unnecessarily why we want to connect it like that. So if at all in the design aspect, if they said the traffic management and if at all then that's good, then you can do it. Okay. So but again still only to go for this one, there's no need to connect it. That's what I think, because if you connect it, then you have the connectivity between these routers, and only to check those connectivity you have it. Okay. So
What
whereas
I'm saying is, if we connect the Airtel router and BSNL router, they can, exchange the hello directly,
Yes.
not through the switch.
hello, but okay, let me tell you. Hello, when you configure, so it can't be configured like that. So you are configuring. So here the virtual IP. So this IP and this IP would be different, right?
Yes.
So when you configure
Yes.
the SSRP, you will be configuring this in the LAN interface. Okay, and you will be giving the virtual IP of the same range of this LAN. Okay, so that should be in the LAN itself. Got it?
Okay.
Yeah. Okay. Any other doubts? Okay. Clear? Okay. Now the next thing. So now what is it? Which is it? So now FHRP is also done. Okay. So now guys, next thing we'll go with, say this one, QoS, traditional versus SDN. So we'll go with these things as well. Again, these are also theory. Okay. So today is Wednesday, right?
Yes.
Okay. So guys, let me pause recording. Okay, so today guys we'll go with this QoS and traditional versus SDN. Okay, now just a moment. Okay. Okay, now so the QoS, quality of service. Quality of service. Okay, so quality of service, it defines how you can customize the network characteristics. Okay, so suppose that you got some packets, the router will receive multiple packets, right? So lakhs of packets in a second. So when he is receiving lakhs of packets in a second, how these packets need to be processed, that's what it's defined in the quality of service. Okay, so if at all you receive a video packet, and if at all you receive a voice packet, and if at all you receive an HTTP packet, how to process it, that's what discussed it in the QoS, quality of service. Now let me tell you, so if the video packet is received or the voice packet is received, these are the time critical. Suppose we are doing the live calls, like the Zoom calls. So these are, say if at all I'm sharing my screen, or if at all I'm telling something, then those things are, say, the live recordings or the live things here. Okay, so they needed to be provided with the greater bandwidth, right? They needed to be provided with the lesser delay. They needed to be, say, provided with lesser jitter. And as it's the UDP, they needed to be provided with the lesser loss as well. Yes or no? Okay, so if it's the video packet, the greater bandwidth should be provided, lesser delay, lesser jitter. Jitter means variation in delay. Variation in delay is called jitter. That means if at all I am sending something from the source to the destination. Okay, so when I am sending from source to a destination, say the first time it takes 3 milliseconds. And the second time, if it is again taking 3 millisecond, the variation in both the cases, it is 0. Right? If at all it's taking 4 millisecond, then 1 millisecond is extra. That means 1 millisecond jitter is there. Okay, 1 millisecond, say, variation is there. So for better communication, the jitter should be minimum. The jitter should be 0. Okay, so these network characteristics can be managed by using this QoS. So you got some QoS tools here. Okay, let me tell you about the QoS tools. The first tool is marking and classifying. Marking and classifying. So marking and classifying means I want to mark it. Okay, so I want to mark it in the sense, suppose, say, whenever you receive certain package, you can mark it as important. Okay, whether it is important or not. So this marking, okay, so based on the marking only the router processes the packets. Okay, so the markings are done, say, in the IP header. The markings are done in the IP header. In the IP header, I may have taught you about, say, a field called typo service field. There's a field called typo service field, and in the typo service field you will mark it, and you got several markings. Okay, if you mark something like this, EF53 or EF52, then EF means expedited forward. That means it is very important. That means expedited forward is considered to be the most premium packet in the user frames or the user defined packet. That means whatever that we are sending, that is the user defined packet. So the user defined packet, the expedited forward or the EF is considered to be the most premium packet and will be considered with the most higher priority. Okay, then comes the AF, assured forwarding. Assured forwarding. Then comes something called BE, best effort delivery, like that. Now, so these are the user defined traffic. Okay, apart from the user defined traffic, you have some more values, NC and IC. IC and NC. IC and NC are considered, so, the highest priority traffic, and this is reserved for the working of the router or the switch. IC means inter-network control and NC means network control. So NC is considered the highest of all. So NC, because within the network for the spanning tree messages and all, this is NC is the, say, one. NC is that one. So for OSPF related things and everything, it is the IC. Okay, so now considering the user defined, EF is considered as the highest prioritized. Getting it? So markings which are done in the IP header, these are the markings there. Clear? Okay. Now, then, say in the switch also you can do the markings. In the switch, when you are passing it through the trunk link, when you pass the frames to the trunk link, that too in 802.1q trunk, I have taught you that they will add a 4 bytes tag. In that 4 bytes tag, you got 3 bits field. You got 3 bits field, which is called class of service field, where you will do the markings in the frame. Clear? Now, once the markings are done, then, or the markings are read, they will classify it. They will classify it. Okay, they will group it into various things. They'll classify into according to the protocols. They will classify it. Then the second tool is the marking tool. Sorry, marking and classifying. Then queuing tool. Queuing means, say, queuing or arranging or, say, separate. You are already separated. Now that you will make them in a, say, or arrange them in particular queues. If it's the video queue packet, then it will be arranged it in the video queue. If it's a voice packet, it will be arranged in the voice queue. If it's an HTTP related or the batch application, that means a normal application, then you will be arranging it like that. So you will be made to put, you will be putting these packets into the queues. Clear? Then say the next one, the next tool, scheduling. Okay, scheduling. So classifying and marking, queuing, scheduling. Suppose you have, say, queued it. Say 50 video packets are there in the queue, and 50 voice packets are there in the queue, and 100 HTTP packets are there in the queue. Then suppose you want to send this through an interface. You want to send all these packets through an interface. Suppose fast internet 0/0. Then fast internet 0/0 will be able to send 100 megabits per second. So they will be able to send 100 megabits per second. Consider each packet is of 100 megabits 1 megabit in size. Each packet is of the size 1 megabit. Then in a second, how many packets can be sent? 100 packets can be sent. Am I right?
Yes.
Okay, in each second 100 packets can be sent, of which, say, suppose scheduling means in that second how many video packets can be sent, how many voice packets can be sent, how many HTTP packets can be sent. Scheduling, that is called scheduling. So in that second or in that instant, you may send 20 video packets, then 10 voice packets. Okay, and then suppose, say, there are 70 HTTP packets. Clear? You will schedule it like that. So that's the scheduler. Clear? So when these are the process, what happens when, say, the router receives a packet, right? When the router receives a packet, the packet will be, say, decapsulated and will be read, right? So it will be, again, you got the ingress queue and the packet will be moved to the ingress queue. Then the packet will be read and the packet will be forwarded to the egress queue. So while forwarding it to the egress queue, it will be made, or it can be marked as important or not. Then what it can be done is that it can be made to queue, and then it will be scheduled, or it will be like the scheduling will be done. Clear, guys? Okay, now the next tool is that policing. Policing means, suppose, just let me tell you an example of policing. Okay, suppose you have taken from the service provider, you have taken a 100 Mbps connection. From the service provider, you have taken a 100 Mbps connection. So this is the 100 Mbps line. 100 Mbps. So now suppose that if at all you are sending the data at 105 Mbps, this is 105 Mbps. So 5 megabits you are sending extra, right? 5 MB you are sending it extra. So what the service provider will do is that he will cut it off, because you have taken only 100 Mbps connection, and if you are sending the data at a greater rate, it will chop it off. And this process is called policing. It comes in the traffic management. Okay, so it will get chopped off. So it is done, say, this policing is done at the service provider side. Now, to avoid being policed by the service provider, you will use a concept called shaping. That means, suppose in the first instant you are sending 100 megabits per second. Okay, sorry, 105 megabits per second in the first instant. Okay, then suppose in the next instant you are only sending 90 megabits per second, right? So you are only sending 90 megabits. So this 5 megabits which is extra can be delayed and can be sent in the next instant, so that you will be sending 95 megabits per second, right? And that is called shaping, delaying the extra bits for the next instant so that it will not get policed. So that is called shaping, and that is done at our end. Clear? So these are the QoS tools. Got it, guys? Okay. Again, these are the theory portions. They are mentioned much more in-depth things. You can read it. Okay. So they are mentioned about the expedited forwarding, that marking. Okay, expedited forwarding, assured forwarding, and all. Okay, more into those things. Okay, you can read it, and in case of any doubts you can ask me. Okay, now the next thing, traditional versus SDN. Okay, so this is a new concept. Okay, this is a new concept in the sense, so far we have been studying about traditional networking. So far we were studying about traditional networking here. Let me tell you what is traditional networking. Okay, consider that you got some routers. R1 is connected to R2, then R2 is connected to R3. Okay, now all the three routers here, they will have, so the routers, they got three planes, or the routers are working in three planes, you can see. The first is called data plane. Okay, and the second is called control plane. And the third is called management plane. Data plane, control plane, and management plane. So all the routers here got, say, data plane, control plane, and management plane. All the three routers. Okay, so say, let me tell you the management plane. Management plane is responsible for, say, accessing the router, for managing the router, taking the SSH connection like that. Okay, for managing the router. Now, control plane, it is responsible for the protocols like OSPF or EIGRP. Okay, so see, the control plane, if the OSPF is working, so I told you that the routers will send the hello packets, they will form the two-way, they will form, say, they will be sending the LSAs and all, right? And they'll come to know about the, say, network, and they will maintain the values in the, say, the routing table, or they will maintain the, or they will keep the router, I mean the routes in the routing table. So those things are taken care by the control plane. Clear? So suppose you got a 10 dot network here, 10.0.0.0/24. So in the router's routing table, R1's routing table, you will have 10.0.0.0/24 in the routing table via OSPF, because that is the part of the control plane, and control plane performs the function. Now, only if the control plane performs the function, then the data plane can work, because data plane will be processing the data. It will be processing the data. If at all this router receives a packet destined for 10.0.0.1/24, then only if the control plane works correctly, then he will be able to get the route in the routing table, and he will be able to forward the packet to the network. Clear? So the data plane is responsible for, so whenever he gets the packet will get de-encapsulated, then will be passed to the network layer, the destination will be read, and the forwarding decision will be taken. Then again through this interface it has to be forwarded, so again it will be re-encapsulated. Clear? So all these things are done by the data plane. Clear? So these are the traditional networking. Clear? Now we are moving into something else, and that is called software defined networking. Software defined networking, or we'll call it as SDN. We'll call it as SDN, software defined networking. Suppose in SDN, if you have the routers R1, R2, R3, if you have the routers R1, R2, R3, then say, suppose that here this is the data plane, R1's data plane. Okay, and suppose this is R2's data plane. Sorry. Okay, so these are the data planes. Now, so here, let me again draw it here. So all the routers, or each router has got their own data plane, but the control plane, they do not have the separate control plane, but they have a control plane which is, say, it is a centralized one, and this centralized control plane is situated in some other device. It is situated in some other device. Okay, so they have the control plane which is situated in some other device, then that is the centralized control plane, and that is called the controller. What is it called? Controller. Okay, so the controller will be in different device. Okay, the controller will be in different device, and of course, say this controller can be controlled by using certain applications or using certain softwares. Using certain applications or softwares, we can control this controller. So it is developed by the developers and all, and we will use this application. So this is the software defined networking, because with the software or with the application will be controlling the control plane, and the control plane will in turn control the data plane of the devices. Clear? Okay. Yes. Now again, let me tell you. So I told you the controller or the control plane interact with the data plane, and that is called southbound interface. What is it called? Southbound interface. Here I'll be teaching you some terms here. That's it. Okay, so here you got southbound interface, which is the interaction between the controller and the control plane and the data plane. So the controller will have certain programs, and the data plane also will have certain programs inside them, and through an API, the application programming interface, they will communicate each other. Same thing, the applications will have certain programs running inside them, and the controller will also have certain programs running inside them, and via some API or the application programming interface, they will communicate with each other, and that communication is called NBI, northbound interface. Getting it? So the interaction between the application and the control plane is called NBI, northbound interface, and the interaction between the control plane and the data plane is called southbound interface. Clear? Now, so what happens is that we will say use this application. Okay, we will use the application, and for application to work, they need some data. They need some data. So R1, it is serial 0/1 is connected to R2 serial 2/0, like that. They need the data, and the bandwidth is 1.544 Mbps or whatever is the data. They need it. So what the application will do is that they will send certain messages to the control plane. They'll send certain messages to a control plane, and these messages are called CRUD messages. These are called CRUD. CRUD means create, read, update, delete. Create, read, update, delete. These are the CRUD messages. Okay, now so they'll be sending certain CRUD messages. Okay, and the controller will in turn send back, say suppose if at all they need to read something. Okay, what is the bandwidth, or what are the say if at all they want to read, then they will send some read message. Okay, I want to read it, so send me the value. So they will send these values. Okay, and those values will be sent with a specific format. You got some specific format, which is most commonly frequently used format is the JSON format, JavaScript object notification. Okay, so the data will be sent with a specific format, the JSON format, JavaScript object notification. Now they can also use YAML format, or they can also use XML format as well. Okay, getting it, guys? Okay, and here the CRUD messages are similar to the HTTP messages also. Okay, you can correlate that to HTTP messages. That's what we call them as HTTP verbs. Okay, now again, so what we will do is that from the application we will control the application. Okay, and from the single application you can say you will do all the configurations, or you will push the configurations to the data plane of the devices. So that means you don't have to do the configurations for each and every router. From the control plane will push the configurations to the say each and every router. So you don't need to access and configure each and every router. Got it? So that's the advantage of this SDN, software defined networking. And another advantage is that if you go with the SDN, you can implement automation. So automation means you can automate the commands and everything. You can automate. Okay, automate means automatically it will be pushed. Okay, suppose that if at all I want to configure the IP address, so I'll have to type the commands like this, right? Say IP space address space. I'll have to go to that interface. I'll have to type the command IP space address space, whatever the IP I need to type, and then I need to type it. So instead of typing that, say the router will be asking, or we can write certain script. We can write certain script in the Python or some other things. Okay, so you can write certain script which will ask for the IP address. What is the IP address? Then you just need to type the IP address. That's it. You just need to type the IP address. You just need to type the, say, the subnet mask and all. So not the subnet mask, even the prefix length, that will be converted to a subnet mask. You can write certain script so that everything will be, say, done by the script itself, and then it will be deployed to the router. So you don't need to configure the router like using these commands. Clear? Now the automation can be done using the tools like Ansible, Puppet and Chef. So these are the tools. Ansible, Puppet and the Chef are the tools through which you will do this automation. Clear? Okay. Now again, software defined networking, the history, some history. Okay, so SDN, the, say, suppose you got of, or all the researchers, they started researching this software defined networking technology. Okay, they started an organization called ONF, Open Networking Foundation. Then they have developed the first SDN model, something called Open SDN or something. They have developed the Open SDN model. Then Cisco started researching on their own. Then Cisco started researching the SDN at the WAN level. They started researching the SDN at the data center level. They started researching the SDN at campus level. And they came up with certain technologies. And the SDN, Cisco's SDN, which can be implemented in the WAN, that is called SD-WAN technology. Okay, now what you implement in the data center, the SDN implemented in the data center, that is called, say, ACI, application centric infrastructure. Okay, and say the SDN feature which can be enabled in the campus network, that is called SDA, software defined access. Okay, so when you hear the SD-WAN, you need to understand it is the WAN technology, it's the Cisco's WAN technology, Cisco's SDN technology implemented in the WAN. Now SD access, it is the Cisco's SDN technology which is implemented in the campus network. Clear? Okay. Now one more thing. So SDA, so it uses a controller. So here everyone, all this method, they use certain controllers, and SDA uses a controller called Cisco DNAC. Okay, so DNAC, it's a controller. It is used by the SDA, software defined access, that too in the campus network. So DNAC means DNA sender. It's a controller. Clear? Or even I forgot the full form, even digital network, something like that, not the architecture, I forgot that. Okay, so the DNA sender, it's a controller which is used in the SDA. Now talking more about the SDA, you got, so winding up guys, just let me tell you this also. So the SDA has got something called fabric. Okay, something called underlay and overlay as well. Underlay and overlay. So underlay means, say, the physical, suppose if you have certain switches connected to each other, switch 1 connected to switch 2, connected to switch 3, connected to switch 4. So these connections, the physical topology is called the underlay. Now suppose from switch 1 you are connected to switch 2, okay, or switch 4 through a tunnel. Through a tunnel means in between you will have some devices and you have, say, encrypted or encapsulated with, say, some values. Then these tunnels, these are called the overlay. Okay, and this environment which consists of the underlay and overlay, it's called fabric. Get it, guys? Okay, so these are the basic things of the SDN. Okay, now again they have given more about this, have a one chapter itself for the SDA. Okay, so you can read those theory things. Again, they have mentioned about the tunnel things, they have mentioned about many values. Okay, it's not really necessary to know that, but still you can read it, and in case of any doubts you can reach out. Okay, they have mentioned about the Ansible, Puppet and Chef also. They have mentioned in the textbook. They just mentioned some theory aspects of those things. Okay, and the SDN things and the those things and all will be say later discussed in the NP level. Okay, you will have some wider aspects being discussed in the NP level. Got it, guys? Any doubts in this one? Okay, so what about the online guys? Fine, everyone?
Yes, sir.
Okay, so then that's the traditional versus SDN concept. Okay, now the pending portions are only, so this GR, proxy ARP and ICMP, that will take maximum 15 minutes. Okay, then the wireless, that will take maybe around half an hour. Okay, and I'll try to wind it up. Even the wireless also, you got some theory portion, many theory portions are there, so we'll shorten it. Okay, and we'll have the copy commands also. Okay, so tomorrow I'll try my maximum to wind it up, and day after tomorrow we'll have certain live sessions. Okay, so guys, shall we wind up now then?
Yeah.
Okay, so thank you guys, we'll see tomorrow. Okay, yes. Now
To stop the recording.
yeah, I'll stop the recording. Yes, of course.